Hey everyone, this is a newest offering by Avesha called Event Driven Smart Scaler. This is an auto scaling solution when we already know what is a predefined time slot during which we need a scaling to happen. This is a product that can fit into that place. So let's start with why do we need this event auto scaler? So let's go over some of the examples. So let's assume we have the NBA final playoffs of 2024 for a sports streaming web application, or if we have a scheduled load testing that happens on every Friday on a dev environment, or for an e-commerce website, a Black Friday sale. So these kind of scenarios would require a usage of an autoscaler which can scale pods during these event periods. Now, for cost optimization purposes, we need to downscale all the pods once the event is over. Also, to support the traffic post event, we need to gradually cool down and we need to have the support for that. We need to have control over the scheduling of the auto scaling process. And this autoscaler should adapt to the application changes. Now, Avesha came up with the solution for this. So let's see what is a event autoscaler. So Event Autoscaler is a GitOps friendly solution which works with Argo CD out of the box. We use scaling factors like 10x, 20x to identify the increase in traffic and accordingly scale our applications. We can schedule multiple events and multiple applications within a cluster. The autoscaler takes care of upscaling the pods during the event schedule and automatically reset it once the event is over. It also allows a gradual cooldown after the event is over to support further traffic. Also, when used with Smart Scaler, which is another product from Avesha, you can check more on Avesha's website. We can also automatically detect the service relationship and the scaling ratio between the services. So for instance, if our front end is the entry node, what would be the recommendation service, which is another service, the number of pods required for that service. So those kind of smart relationships are automatically identified by Smart Scaler. It also calculates the normalized min-max based on the traffic patterns. So that's something when used with Smart Scaler, it's going to be beneficial. Let's go over the components of Autoscaler. So on the left hand side, you can see there is a boutique application which gets deployed on the cluster via Git repository using Argo CD. So this is a GitOps approach where we have all the manifests defined in a Git repository, and then Argo CD is configured to pull in the changes onto the cluster. On the right hand side, we see the autoscaler components when plugged in the cluster. So it has two pods, agent controller and Git operation service. It has three CRDs, application config, scaling ratio config, and event config. Along with that, it also has some global configuration which can be set by setting autoscaler configurations. This is a config map that comes with the package. The agent controller will connect to Argo CD and listen for or identify all the applications, all the services associated. The Git operation service communicates with the Git repository to raise PRs, create branch, and all the tasks related there. The configurations for the autoscaler can be done using these CRDs that we have already mentioned. So we'll see more once we enter the live demo. So let's first see a user journey how we would start or set up configure event autoscaler. So the first time action that a user needs to do is define the application. So a user can define the whole application, including its individual components, all the services, or they can simply refer to the Argo CD application manifest and our autoscaler will auto detect all the services and scaled objects. The user will then create an event CR for a future time by defining the scaling factors. Just before the start of the event, a PR would be raised following these scaling changes, and PR will be merged uh, to the base branch. Now from here, Argo CD will take care of deployment back to the cluster. Once that is done, we can verify that on the cluster that the min factors or the max factor that we applied is currently available on the cluster. Next stage comes when the event is over. So let's say our event was of 1 hour. After that 1 hour period is over, a PR again will be raised to reset the min values that we modified. This is basically bringing down all the scaling factors that we did on the first PR. Now, after the there is a cooldown period that starts now. So this is to support the traffic that still lingers when the event is over. Now, once the cooldown duration is over, another PR will be raised to reset the max values that we have modified. The controller will also observe for any config drifts and alert by raising Kubernetes events. Let's go over one of the example how scaling factors will come into play. So let's assume our current minimum and current maximum is set to 1 and 30 respectively for front-end service and ad service. These are the two services present on our application. Now, as we apply a scaling factor of 20, that means scaling factor of min is 20 and scaling factor of max is 20. These are the boundaries we want to set now. So during the event, the calculation would for front-end service, which is the entry point, is going to be the current min multiplied by the scaling factor. That is 1 into 20. That gives us 20. Same for the max. That is going to give us 600, 30 into 20. Now for a non-root node or a leaf service, we also defined a scaling ratio. So in this case, we see an example that we have 0.116 with respect to the root node or the front-end service. So ad service is 0.116 times of that of the front-end service. The same scaling factor will be applied here. Now the current min multiplied by scaling factor multiplied by the scaling ratio gives us 3 for the min and 70 for the max. This we'll see on a better manner once we have the live demo in action. So let's quickly go to the live demo and see how things are working. Yachika, can you take over?
Yeah, thank you, Prank. Yeah, so in this demonstration, we'll be using the famous boutique application. So this is the UI of the application. It consists of multiple microservices. This application is deployed via Argo CD with autosync enabled. What it means is Argo CD will continuously polling for the GitHub repo for this application, and it will see if there is any change in the repository. It will try to bring the same change on the uh, clusters as well. So basically, it is syncing those changes. I'll show you the GitHub, the Argo CD UI first. So this is the application which is created on the Argo CD. Boutique is the name, and then it is all healthy and synced with the clusters. I can show you the services and deployments. It consists of these many services and these many deployments. Let's say checkout, currency, email, front end, and all that. So this is the GitHub repo of that application. All the Kubernetes manifests are here. Let's say these are the all the deployment files for the services. Then these are the scaled objects. Let's say so scaled object is something coming from KEDA. KEDA is a event-driven auto scaling. And these are the scaled objects, custom resources from KEDA. This is where we should tell that how the scaling of a particular service should happen. So minimum and maximum replica count for, let's say, front end is 1 and 30 in a normal scenario. And So the triggers of this, sorry. So the triggers of this application is smart scaler. So the actual value or the current value, what the current value for this service is coming from smart scaler in this application. So now let's go to the environment. So to install our agent controller, the event autoscaler, uh, you'll have to install the Helm chart. So once you install the Helm chart, you'll get these two pods. One is agent controller manager, another is git operations. Agent controller manager is the controller manager for all the custom resources, uh, which Priyank showed, application config, event config, and scaling ratio. And then there is this Git operation server, which is responsible for all the GitHub actions. Now, I'll show you the application config custom resource. So once you install these Helm chart, after you get these two pods running, what you have to do is you will create a custom resource application config. This is a one-time event. So what you are doing here is registering your application with our agent controller. So basically, agent controller needs to know what is the application, and this application is deployed via Argo CD. So we are taking the advantage of the same application via Argo CD. So what it's saying is we mentioned the API version, the kind, which is application config, metadata.name is boutique, and then the spec, under spec we give the Argo CD application reference, the name of the Argo CD application, and the namespace. So if you install if you deploy application using Argo CD, Argo CD will create an application inside the Argo CD namespace with the name you have created, right? So it was all the services, the boutique, the application services, right? And it has all the GitHub configuration. So we are directly taking all this configuration from Argo CD. So user doesn't have to manually write or update the agent controller's custom resource manually. Second comes, so before that, the prerequisite for application config to automatically detect all the services and GitHub configuration is to label a secret. So Argo CD is creating a secret in Argo CD namespace for all the applications. So let's say for this boutique application, it has created a new secret repo and with some unique ID. And all the GitHub related configuration stays here in this secret. So we'll be also using the same secret. You don't have to do anything extra. What you need to do is just label this secret with agent controller label as well. So if you see the Argo CD label is also here. So similar kind of label, just the prefix will change. You'll have to add it here. Once you add the label and create the application config, agent controller will automatically detect all these services. So this was about the prerequisite. Once the application config is created, the agent controller will keep on pulling the Argo CD config changes also. So if there is any service added or removed, the application config CR will automatically update itself. So this is one advantage of automatically detecting everything. And then comes the second custom resource, which is the scaling ratio. So this is same API version, kind as scaling ratio config, metadata name, I've kept boutique. And then under spec, you will mention all the scaling ratios. So scaling ratios, under scaling ratios, what you have to mention is the scaling ratios for all the services which are present in your application, right? And here, what it's saying is the source is the front end, target is the ad service, wait is this much. What this means is, in our application, front end is the entry point for our application, and uh, all the services are like child for those for that uh, front end root node. So that is why with respect to front end, the weight for add service would be this much. So let's say if front end is 1, the add service would be 0.116. The value, the weight of that service is this much. And for card service it would be 0.512. So it is different for all the services, depending on the traffic each service is getting. So this file is, these values is something which we are getting from Smart Scaler. It has provided us. A user can also configure it if you want something, another value or another uh, weight for any other service, right? So let's go ahead and create all these custom resources. Let's start the script. I'll expand this. Firstly, it is listing all the deployments in the boutique namespace. These are all the services, and it is everything is in ready state. I'll click continue. It is applying the application config YAML, which I showed you earlier, this one, which has Argo CD application reference. Now what it's doing is waiting for application config to be in ready state. So for an application config to be in a ready state, what it needs to be have is it need to have all the services which are present in Argo CD application, and then it should have all the GitHub configuration, and then it will mark itself in a ready state. Let's see. What I'm doing here is getting all the application. One second. Sorry. So what it's doing is getting all the application config in a boutique. Sorry, getting all the application config boutique and just printing it in a YAML format. If you see the application details, these are added here with the secret reference as we labeled in Argo CD namespace. This is the repository, and these are all the services which are present in that service, right? This everything was automatically detected, and the status, if you see, it is in ready state. So I'll go ahead and click continue. Now I have applied the scaling ratio also, which is created. Now all the one-time event is done. We are ready with the application. We have our scaling ratios. Now let's say we want to create an event. I'll show you the event config for that. Event config is also a custom resource. For an event to happen, we need to create a similar kind of resource with same API version. Kind would be event config. Name I have kept Black Friday Sale 2024. Event name is also I have kept similar, but you can keep it like a label thing for this event without hyphens and all. Event start time. So event start time is something when the event is going to start. Event end time is when event is going to end, the timestamp of that. Application config name. So for which application this event is going to be. So this is the name of that application config which we have created earlier. So the name is boutique here. So I have mentioned it here, referencing it here. Scaling ratio config name. Again, this is the name of this scaling ratio. The name is boutique. I've mentioned it here, same. Now you can create multiple scaling ratios based on your event, and you can map it here. So let's say there is one more event, but the scaling ratio is different according to, let's say, some more traffic, then you will add the scaling ratios accordingly or refer them accordingly here in the different event for the same application. Now scaling configuration. Under scaling configuration, you have to mention min scaling factor, max scaling factor. What it means is, so for example, for my traffic, I'm expecting that my traffic would be 20x of what it is now. So that is why I have mentioned it as 20. So this is something like 20x traffic is going to increase during the event. Then comes a cooldown configuration. Here you have to mention the cooldown duration. So this is the time period, wait time period after the event ends. So in this period, after the event ends, we don't suddenly decrease the pod count on the cluster. We wait for this duration, and at the end of this duration, we try to uh, update the maximum replica count also. So we gradually decrease the pods after the event end also, so that we don't have any traffic loss. So let's say we don't get there was event, there was 20x traffic, but at the event end also there was traffic on the clusters. So we don't want to lose that traffic. So that is why we have kept a cooldown duration of 4 minutes as of now, because this is I've kept shorter for the demo, but normally it would be in hours, let's say 1 hour or 2 hour. Yeah. So I'll update these values. I'll start it at 17, and then let's keep it for 10 minutes, and then yeah. So we'll start it at 12:17, we'll end it at 12:27, and then the cooldown duration would be 4. I'll go ahead and continue. I'll create a new event config was created. Continue. Now this is watching for event state transitions. So what will happen now is, so what we are doing here now is, we'll see the event config agent reconciler, which is running in agent controller manager. It will see that okay, event is about to start. So it will modify the files uh, according to the event, according to the min max scaling factors, according to what was earlier there, and according to the scaling ratios. It will modify the files, create a new branch on the GitHub repo, and then raise a PR from that branch. And it will automatically merge also that PR. That automatic merge is a flag which we have mentioned in a global configuration, which will come to that, will come to that later. But it will automatically merge the PR also, and then we'll see the exact same min max updating on the clusters as well. I'll show you the logs of the pod. So it's saying that it raised this PR, uh, and it has automatically merged too. So this you can see a new PR was raised with this prefix. Uh, I'll show you a global configuration where I've mentioned everything. So this all is dynamic. It's saying it was updated for this event. The event name was Black Friday Sale 2024. And then the base branch is demo prep. This is mentioned in Argo CD. Argo CD configuration, and then the private branch is Black Friday Sale 2024. So this branch is the event name. So we have created the same name as the event name. And then you can see a nice description with saying the event name, the operation, it was update scaling values. This is a custom message. You can edit this message also in that configuration. And then this PR was raised by event-based autoscaler agent. Now we'll see the file changes. Let's say for front end, all the services, this is a scaled object for front end. All the services had min and max replica count as 130, 1 and 30. But during the event, it will change. It will scale up, and the expected value was 206 to 20 and 600, as we show as Priyank showed earlier, the calculation part. Like the 20x was the scaling factor, so we multiplied 1 into 20, which is 20, and then 30 into 20, which is 600. Based on the scaling factors, we calculated it and we got the correct value here. And then let's say for ad service, the expected value was 3 and 70, and same we have got it here. And we got a comment also that this was updated for an event and then the event name. So now what we have achieved is a PR which is merged to the base branch. And after merging the PR, what we do is we automatically delete this branch as well. So we don't clutter the GitHub repository. And you can see all these PRs, whatever it was merged, what were the earlier commits in that PR, everything you can see in the audit trails of GitHub repo. But we delete the branches so that we don't clutter with unnecessary branches. Yeah, so let's go to the application. What is happening here? Let's see. Sorry, I was going to refresh. I'll refresh this page. Yeah, you can see it is all synced. This is the last commit which was added by event scaler, uh, event autoscaler, and this is synced to the cluster as well, and you can see it is all healthy. So if we go to the clusters, we'll see the actual size in the pods. You can see this many pods have scheduled now. And if we see the scaled objects, the previous values were 1 and 30, and now it will have these many min max because the event is going on, right? Now what is the time currently? It is 12:20. Our event end is supposed to happen at 12:27. Meanwhile, I can show you the global configuration which I was going to show. If I do kget cm in the same namespace, I'll describe the configuration inside the config map. Yeah. So all this global configuration for your events is mentioned here. These are some default values. Let's say the default creation duration is 1 hour. So what this duration is, let's say there is an event going to happen, and we want to raise a PR, but event is, let's say, suppose to happen tomorrow, which is 24 hours from now. So we'll not create a PR directly as soon as the event was created. We'll wait for this duration for 1 hour, and 1 hour was left, was remaining from the event start time, we'll modify the files and then raise the PR, so that we don't get any unnecessary conflicts, right? Because we need the latest information on from GitHub. So this is that default PR creation duration, which is 1 hour by default. Watch interval, which is 5 minutes for the application config reconciler to watch for Argo CD application. As I mentioned, that whenever there is any service addition or removal, we are automatically polling the Argo CD application, and then we'll see and we'll update the application CR also. So that is that watch interval. It is 5 minutes by default. Scaling controller, these are the we are doing it for scaled object, and this is that. Auto merge enabled. So this is the flag which I was talking about. Whenever you raise a PR, will automatically merge it also. We are not directly merging to base branch so that we don't lose what we have done. We are following the best practices. If you want to merge it automatically, do it with this flag, but we still raise the PR with the branch name and then merge it to base branch. And then some git properties, which has the commit prefix, as you uh, see here. As you can see here, the title of this PR was CI and then updated for event. So this is the same prefix which is coming from this config map. The commit suffix, and then sign off, author name and email. Right now we are using it the customer would be using their own author name and email. PR title format, which is CI, and then the formatter. Description format. So this is what I was saying, that this is what you can edit in the PR. Uh, it's a custom message, and then some PR assignees, reviewers, labels, and stuff. All you can add here in your config map, which is agent controller autoscaler config. Yeah. Right now it's 12:23. And the event end is supposed to happen at 12:27. So these are the states which are these are the state transitions for event which has started. It is in created state, and then it got into initiated state because event was about to start, and then it is progressing. And now at the event end, we'll see a new state which is going to update the min replica count for that application scaled objects. We'll see a new state here. Yeah. reset min scaling values, saying it has created a PR merged, and then it deleted the branch. Yeah. So this is like the same the PR which we saw earlier, the same configuration, only the operation is different. Now it is updating the min scaling. And if we see the files changed, you can see it has only updated the min replica count for all the scaled objects. And you got a comment change also, which is saying resetting values after the end of the event and the event name. Now if I go to Argo CD UI, refresh it, yeah, it's out of sync because of the latest min scaling factor change. It's syncing the change, and now it's synced. If we scroll down, you can see these many pods are progressing. You'll see some pods going down, and you can see some pods are going down now because event end has happened. All these are in terminating state, and we can see the scaled objects min is also updated. Max is same, which was during the event time, right? Now, the cooldown duration was cooldown has also started. Cooldown duration was 4 minutes. We'll see a third PR in about a minute with which will update the max scaling replica count also. Yeah, now we should have a new request. Yeah, it's 31. 4 minutes from 12:27, we got a new request, which is to update the max scaling factors. It's saying the PR created and merged and deleted the branch. Yeah, you can see a new PR in the same manner. The operation is update max scaling now. And if we see the file changes, it has updated the maximum replica count for all the scaled objects, and it has decreased it to the original values which were there earlier before the event. And then it has added the comment also that resetting values after end of cooldown duration event and then the event name. If we go to Argo CD UI, it's again progressing, syncing the changes. It's synced. Now the pods will be in terminating state again. Yeah, if we see the scaled objects, the max is also reverted back. If we see the deployments, boutique namespace, yeah, it has come to a lower number.
So Yachika,
Now,
this
yeah,
marks the end of the whole event transition, right?
yeah, yes, right.
All
So if we
right.
go to event transition also, it said reset min scaling and then cooldown, then reset max scaling values, and then it is in completed state now. And stop the script.
Great.
Uh,
Yachika, can you pull up the dashboard,
yeah,
the Grafana dashboard that we have?
yes, yes. Just give me a second.
All right. So this was a recording that we did here for whatever happened within the cluster. This is just a Grafana dashboard where we have plotted some lines uh, of various data points that we gather. So let's explain what this chart is representing. On the left hand side, on the y-axis, we see the RPS, which is the request per second. This is used for the traffic analysis, the error analysis, as well as the predicted RPS that happens from Smart Scaler. On the right hand side, we see number of pods, and on the bottom is this the timeline that we are following. So we saw the event was created during 1745 in local time, 1746. So if we see the green line, Yachika, if you can just click the green line. Yeah, this is the traffic pattern we ran throughout this event duration. So it started with very low amount, 60 to 100, and then scaled up a bit to 400 plus. Now, after that, it decreased down a bit, did not go completely back to 100 and 150 variation, but rather stayed a bit higher than the whatever spike we wanted to simulate. Now, during this time, if we see, if we just open the pod scheduled, we see that it started with uh, initially with just 1 2 pods, and then scaled up to 20 pods. The reason it happened is because we had already set the min values during this event duration, and that's what we are seeing here. Now, once the event was over, it dropped down to whatever was needed at that duration. Now, how did we calculate the needed duration or needed number of pods was through the smart scaler. So right now the services are all connected to smart scaler via scaled object triggers. So it's looking for queries from smart scaler and then applying the current number of pods. So if we expand everything, we can see the graph which shows in the purple line, that is the predicted RPS by smart scaler. It almost follows the pattern of the traffic, and we can easily determine by the sky blue line, which is the number of pods suggested by smart scaler that would be required for that RPS. So even during the event duration, the traffic wasn't high enough to exceed the recommended load. It was sticking to 10, 12 pods, number of pods. But since we had a cap, the minimum cap of 20 pods, this traffic was also handled, and Smart Scaler kept on recommending the lower numbers. Now, as soon as the event ended, we observed that Smart Scaler is coming into play, and the scaling did not go down back to 2 pods. It kept basically it stayed where whatever the Smart Scaler was recommending, which is 8 pods for now, which would be useful for the traffic that we are currently experiencing. So this was overall the summary of what we observed during the event autoscaler period, as well as with the suggestions of smart scaler. So this sums up the demonstration of event autoscaler and how it can be used with smart scaler.